All right, let's jump right into a topic that's honestly a total cornerstone of algebra: perfect squares and square roots. You're going to see these everywhere, so getting a solid grip on them now is going to make things so much easier down the road. So, you ready? Let's do this.
So, before we get into the fancy terms, let's just start with something super simple. What do you call it? What happens when you take a number and multiply it by itself? Just think about that for a second.
Okay, so take a classic example, right? 7 times 7 equals 49. We all know that. But there's a special name for this process, for this result, 49. Any ideas what it is?
Yep, you got it. It's called the perfect square. So that 49 we just talked about, that's a perfect square. Why? Because you get it by multiplying an integer, in this case 7, by itself. Pretty straightforward when you break it down, right?
Okay, so let's really dig into what a perfect square is. I like to think of it like building with blocks. Seriously, the name perfect square isn't an accident.
The process is always the same, and it's super simple. Step 1, just pick an integer. Let's go with 5. Step 2, multiply it by itself. So 5 times 5. And step 3, the result you get, 25, that's your perfect square. That's all there is to it.
And here are a few more examples. 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9, and so on. See this list? 1, 4, 9, 16, 25, 36. Trust me, these numbers are going to become your best friends in algebra. You'll see them pop up over and over again. Getting comfortable with them now is a huge head start.
Okay, so here's a cool thing about math. Pretty much every action has an opposite, right? An undo button. So if we can square a number, there has to be a way to unsquare it. And that, my friends, is where square roots come in.
Think about it this way. You know how subtraction is the opposite of addition, right? And division is the opposite of multiplication. Well, the square root is the exact same idea. It's the operation that undoes squaring. They're a perfect pair.
So let's just work backwards from our last example. We start with the perfect square, 25. Then we use this little checkmark looking symbol, the square root symbol. And what this symbol is really doing is asking you a question. It's saying, hey, what number did we multiply by itself to get 25? And we already know the answer to that. It's 5.
And hey, let's learn the lingo so you sound like a pro. That symbol, the square root sign itself, that's called the radical. And the number tucked inside it, that's the radicand. You're going to see those words in your homework and textbook, so it's really good to know exactly what they're referring to.
Okay, enough with the theory. We've got the main idea down. Now let's see how this actually works with some real numbers. Let's put it into action.
All right, here's a quick one for you. What is the square root of 9? You're basically asking yourself, what number times that same number gives me 9? And the answer is 3. Of course it is. Why? Because 3 times 3 equals 9. Simple as that.
Okay, let's try a bigger one and really break down the thought process. So you see square root of 64. The question that should immediately pop into your head is, okay, what number when I multiply it by itself gives me 64? You kind of scan through your mental multiplication table. 6 times 6 is 36, 7 times 7 is 49. 8 times 8 is 64. And you can always double check. Does 8 times 8 equal 64? Yep. So your answer is 8.
Okay, hang on. We need to talk about something really important here. This is a super common mistake, and I want to make sure you don't fall into this trap. It all has to do with something called the principal root.
So here's the puzzle. We all know a negative times a negative is a positive, right? So negative 4 times negative 4 is 16. But positive 4 times positive 4 is also 16. So when we see the square root of 16, what's the answer? Is it 4? Is it negative 4? Is it both?
This is where we need to be really clear. It's totally logical to think the answer could be both positive and negative 4. But in math, we need one clear, unambiguous answer. So, a long time ago, mathematicians made a rule, a convention. And the rule is that radical symbol, the square root sign, specifically asks for the positive or non-negative root. So, even though negative 4 squared is 16, the square root of 16 is only positive 4. It's a rule you just have to remember.
And that positive answer has a special name. It's the principal square root. That's the official term. So whenever you see that radical sign, your brain should immediately think, okay, they want the principal root, the positive one. That's the key takeaway here.
Okay, we've covered the basics, we've walked through some examples, and we've even cleared up a common tricky spot. You know what they say? The best way to learn math is to do math. So now it's your turn.
Go ahead and pause the explainer right here. Your mission is to simplify this, the square root of 81. Take a moment and figure it out.
All right, you got an answer? Let's see. The correct answer is 9.
Did you get it? I bet you did. The principal square root of 81 is 9. Why? Because 9 times 9 is 81. Fantastic work!
Okay, let's leave you with a little something to chew on. We've just learned that a square root undoes squaring, which is a number times itself. So what do you think undoes cubing a number? You know, a number times itself again. What would that look like?
The answer to that question is your next big step in algebra. But for now, that's all the time we have. Thanks so much for tuning in. Never stop asking questions, and always, always stay curious.